Welcome to Industrial PLC Applications. And this video is on the Bulk Loader Hopper Conveyor Lab. Alright, so with Lab 1, the Bulk Loader Hopper, you had to download a program from Slate and use that as an integral part of the program. So it was called Process, and we're looking at it now, and it wasn't a long program, but it had some key elements that without them the project doesn't work. So this is simulating another PLC, and it's quite often you'll have machines talking to each other, sharing data. Something as simple as I'm turned on, I'm in automatic, and I'm waiting to receive a part from you. Simple things like that. In this particular case, we're looking at a drum replacement and filling monitor machine. So to simulate that action, because we only have the one PLC, a special program was created. And the way the program worked was quite simple. When the e-stop was not tripped, you waited to see for the conveyor at speed. So this global variable, digital output 4, had to be energized from the program that you were going to create. Once that was true, it would initiate a turn-off timer to flash off and on for half a second. Every time it did that, it would turn on digital output 5. Now when you look down at the bottom, digital output 5 in turn would start a count. Once the count reached 20, there's a timer that would be triggered, and when the timer was not done, you would send a bit, turn a bit on digital output 6 to say that the drum was full. Once the timer finished counting after 5 seconds, that would be taken away, and then the drum not full would be turned on. So this digital output again is interlinked with our other program. If you did not connect digital output 4 from the other program or receive digital output 6 from the other program, then your program kind of fell to pieces, or more accurately, likely didn't work the way you would expect it. So the drum in position was made with this particular counter, and it looked for anything less than 19. If it was less than or equal to 19, then the drum was still in position. Once it reached the 20, then that count would then trip up, because this count, we're looking at this counter. So once that was 20, then it was the drum was removed, and you lost the drum in position. You had to wait for it to be back in place. So I've added a program because while I'm talking about this, I wanted to show you some of the possibilities you can use with internal variables, especially if you take a larger variable, a dent, and use it as a construct. So what I did is I created a couple of rungs, and in the rung I made a dent called function, or FUNC, as a dent. Then I can use any of the 32 bits and I can name them, and I can follow through with the required analysis form. I can say, okay, someone's pushed a button, function 1's complete, the master control relay is set, function 2 is complete, right now function 4 is made, and we can look up that and see what that's turning that on. But eventually all of these will be lit up in sequence. So if something goes wrong, I can turn around and say, okay, well, I'm not sure why function 4 is on, but I can go and investigate. And to do that, I can right click on it and go to my cross-reference browser and look for the right instruction. So it's on rung 8, and it says, is the drum in position? Well, currently it is, so function 4 has already been satisfied. So in the program itself, quite a few were on the right track. Some of the simpler processes were taken care of right away. The tricky part was the last part, which I'll get to. So I've got a simple rung here, and my function 1 means the MCR is turned on. In order for me to do that, I simply have to toggle my start button. The MCR seals in, and my function 1 is also on. That starts my warning horn timer. While it's timing, I'm going to put on a horn. When the timing is finished, I'm going to say that it's finished, and I've used a set bit here to say that I've completed that task. Then when that's done, so my e-stop is still good, my MCR is still made, my warning horn timer is still made, and I have another internal variable I've called process not done. And if that's okay, then I'm going to start my conveyor. Once the conveyor starts, it's going to trip a timer to count out, because we want to get that 5 seconds or 6.5 seconds, whatever, up to speed. Once that happens, I set that conveyor at speed. And just to refresh our memory, I'm going to right click on that, cross-reference it, and I'm going to go to the read part, which is in run of our other program. So once I've done that, now I've started the whole filling process. And we can see that the drum filling is going to go off and on based on the timer and the counter and the position of the counter. So I'm going to go back to my right, close that for a minute, and I've set my function 31, because if you read the way the function chart part of the required analysis form was worked out, it happened to be function 3.1, so I said, oh, I got 32 bits, so I'll just call it 31. So if the e-stop is maintained and the system stop's not maintained, and we're at speed, the drum is in position, that's all good. And then we have our drum not full, and again I have this process not done, and that's going to turn on my solenoid. So let's take a look at when the drum gets full. I make my function 6 to say that it's full. It's then replace, it will then go out, and I can keep track. Every time I see function 6 is made, I know that the drum has been filled, and now we're in the midst of changing it. So the hard part of this was to come up with a way that we can say that it's been running, monitor the status of the drum, whether it's full or not, and allow the last drum to be filled without shutting everything down. So what I've done here is I've created two internal variables, one called finished filling, and for that I'm looking at the not system stop. So right now, if I pull my simulator up, my stop is okay, and I want to wait. Drum is not full. I have to wait till the drum is full, and then when that starts the next cycle, I'm going to remove that stop. So it's now filling. I'm going to remove 7. So now, because I've set that, I've set my new internal bit called finished filling. And it's going to go through the whole thing, and once it gets the drum full, it's going to drop that. I set the bit process done, and then that will take and shut down the whole system. And basically allowed the system to fill up the tank, and then in a blink of an eye everything gets reset. The conveyor stopped, and we have to start the system up as we did before. Same thing applies on the other part of the equation, because the other part of it was to ask that you stopped it on a full e-stop. So we start the whole system, I lose the e-stop, and it all shuts down. The part of the overwriting of other parts can be a little tricky. It takes some time and some careful thought, and I did the same thing what quite a few did. I forgot a rung of logic to put some commentary on. Also, there was a requirement for a header rung, and quite a few missed that as well. But that's basically how that program was supposed to work. There was variations on a theme. Some of you came very, very close, but it's one of those ones that takes some careful thought and using some internal variables to help you to set an internal bit that you can then claim that the thing is done. Here's some key points to keep in mind when you're doing any lab. The first thing is read the entire lab. Things were missed by not looking at a different page, especially in the RAF. Some small details might be on a drawing, might be on the line diagrams for the ladder logic. Also, you and miss things. So when the addendums came out, the very last line said to go back and update the RAF, because the RAF is considered to be a living document, and not very many people took advantage of that. The second part, number 2, is don't give away any marks. I mean, create a header rung with your name and project name. That's easy enough. Put comments on every single rung. Make the attempt. There's no sense losing marks because, or not gaining marks because you didn't take the time to type it. I find personally that it helps me to focus on what I'm attempting to do. I write down my thoughts as a comment and then I go back and say, oh, okay. Now occasionally I'll mess up like everybody else and I usually catch them as shown in the video, but you know, just leaving it blank, you're giving away marks. And number 3, program, download, and test. Build 1 or 2 runs at a time, download it and try it. Then build on that success and then fix any mistakes and move on. It's the most progressive way that I know how to program, and it's one that I still use to this day. The program that I wrote that you just looked at, that's exactly how I did it. With that, you should have a lot more success when doing these labs. Until next time, thanks for watching.